Welcome to Altair Engineering Training and Support. I am Apoorv Bapat. Welcome you all in SUPRA SAE India 2016 pre-virtual online training sessions. The agenda of this training session is as follows. In day one, I have covered theory of FEM with 1D meshing, geometry editing and static analysis on the 1D meshed roll cage structure. Then on day two, I have shown you how to do geometry editing on 2D roll cage structure with static analysis on it. On day 3, I have shown you the dynamic crash analysis on the 2D meshed roll cage. Today, that is on day 4, we will see how to do 3D geometry editing meshing of Knuckle hub with combined loadings. And on day 5 and day 6, we'll see the suspension analysis using MPD and CFD using AccuSolve and AccuConsole. So let's start the session with opening of hypermesh. So I will select the user profile as OptiStruct as I'm going to perform the static linear structural analysis. So I'll select the user profile as OptiStruct, click OK. Once I click OK, I'll go to the open folder to browse the file. Open the Knuckle file first. So this is my geometry of Knuckle. So before going further, I will check whether my geometry is properly connected or not. So I'll just go to visualization panel, turn off this shaded and suppressed edge checkbox and see if I'm able to see any red edges or not. So if I'm not able to see any red edges, that means my geometry is properly connected. So we will start with creating material. So to create material, I will click on material collector icon, enter the mat name as steel. We will select a color, type isotropic, card image mat 1, click on create edit, enter the value of E, new row and click return. Again click return. Then the next step is to create the property. So to create the property, I will click on property collector icon, enter the property name as Knuckle, define a color to it, select the type as 3D as I'm going to use 3D elements. So I will select the type as 3D, card image as P solid, material will be steel and click on create. Then I'll update the component. So I will go to component icon, select the radio button as update, select component which I want to update, toggle the no property to property and select the property which I have created earlier and say update. So now I have updated this. Now I will go to the next panel. So now I will go for meshing. So to do meshing, I will go to 3D. On 3D page, I will click on Tetra Mesh. In Tetra Mesh, I will select volume Tetra radio button, that is the third button. In enclosed volume, I will select surfaces. So I will select the surface. In 2D type, I will select R tria. In 3D type, I will select tetras. Check the box in front of use curvature and use proximity. Enter, keep these values as default, that is minimum element size as 0.8, maximum element size 4, or you can say 2 and click on mesh. So once you click on mesh, it will start generating the meshing. So I will say reject as my mesh goes to the different components. I will make this as the current and then again click on meshing. So if your mesh if your component is not correct, then then the software will create one more component and make that as the current component and move the meshing in that component. So it is always advisable to make your component current which you have on which you have defined the property and material. So this is done. So you can see here my meshing is done. If I turn off the geometry, so the meshing is done with the 3D meshing. If I mask it, you can see it has created a 3D elements. Now to proceed further, we have two options. One is, let's assume that I am going to apply a force at the inner surface of this area as a braking, cornering and dead weight or weight of the car on this, some movement here, and going to constrain these points 1, 2 and this point along with this point. So there are two options to do it. I can directly apply a force on each and every node. So to apply these forces and constraint at each and every node, it will be a tedious job. So instead of that, I will create a rigids and I will apply that forces and constraint on those rigids. That will be much more easier. So before creating rigids, I will quickly go to F10 and check for the TED collapse. So I will try to solve the TED collapse which is coming. So I will say 0.1. So 17 elements are failing. So I will click on save failed. Go to mask, elements, retrieve, mask and reverse. So press shift F2 from the keyboard to enter the temporary node panel. So here you can see my elements are failing in TED collapse. So I will just try to increase the distance of these. Similarly, here also, or I can increase the distance in this manner also. Here also I will change the distance, and here also I will change the distance. So I will click unmask all, shift F2 clear, then again go to F10 and check the TED collapse. So again the two elements are failing in TED collapse. I will say save failed, mask, elements, retrieve, mask and reverse. So these two elements are failing in TED collapse. So TED collapse means the height of tetra element, which is very less for these two elements. So I am increasing the height of these two elements. So there are two options to increase the height of these two elements. One is you can increase the distance. The other way is uh, you can translate the nodes. So I am showing you both the ways. So again I will click on TED collapse. Again the three elements are failing. So I will again solve this. TED collapse minimum 0.1 is required. It should not be less than that. So here the TET collapse is coming because of the geometry. So I will find the attached elements and try to remesh it. So I'll go to 3D, tetra mesh, tetra remesh, select the elements and click on remesh. We will see the TET collapse value now. Safe field, element, retrieve, reverse, mask. So this was the failed elements. I will click clear all, shift F2, add the nodes, and F4, F10, that collapse. I will keep these nodes translated on this plane. Say F10, TET collapse. So now all my elements are passing in TET collapse. That is the first requirement before doing anything, like creating rigids and all. First check the elements quality. Then for rigids, I will create a new component as rigids. Without any property, I'll have a different color to it and say create. Then to define the rigids, I'll go to 1D page, rigids. So I want a center node here, which I will give as independent node. So before creating the rigids, I will press F4 from the keyboard, go to 3 nodes, select the 3 nodes here. I'm just trying to find out the center of this portion. So I will just create this node between. So now I got the center of this portion. Similarly, center for this one, 3 nodes, circle center, 3 nodes, circle center. Then go to 2 nodes, node 1, node 2, node between. Similarly here also, 3 nodes, circle center, circle center. Then these 2 nodes, node between. 3 nodes, circle center, 3 nodes, circle center. Go to 2 nodes again, node between. Here also 3 nodes, circle center, then 3 nodes, circle center, 2 nodes, node between. Now here 3 nodes, circle center, 3 nodes, circle center, 2 nodes, node between, and lastly here also. This is required to create rigids. I want a center of this thing. So circle center, similarly these 3 nodes, circle center, these 2 nodes, node between. Now I will turn off this meshing and I will go to shift F2, select the extra nodes which I have created to create the node between, and simply clear these. Just click clear. So now I have these nodes only, which are the center nodes of this. So now I can create the rigid. So I'll select the independent node. Dependent nodes have multiple nodes, and select some of the in between nodes here. Say nodes by face. So it will select all the nodes as you can see here and say create. So my rigid has been created. So whatever force or constraint I will apply, it will get transferred to the entire surface and divided equally to nodes by face create. Similarly, this node by face create. Node by face create. This node by face create. This node by face create. Independent node, dependent node by face create. So now I have the rigids with me on which I can apply the forces and constraints. So I will create different load collectors. Like I will start with SPC, that is single point constraint. Define a color to it and say create. Then I will have one force as lateral, bump, movement, and I will start applying them. So analysis, constraints. So I have 4 load collectors: lateral, bump, movement. If I need more, I will create more also. So I'll start applying the constraint first. So I will make the constraint as the current. So I will select this node, this node, and this one and say create. So I have created the constraints here, you can see, with all the 6 degrees of freedom. Now I will apply some lateral forces. So I will add make current, go to forces. On this node, Z direction 10,000 create, make current Y direction create. I will select the node this and say create, and I will apply a moments at these two nodes. So 5,000 in Z direction create. Similarly here minus 5,000. So one side clockwise, the other side is anti-clockwise. Also I will add different load cases. Like I will see the analysis when all these three will act parallelly at the same moment. So I will add a combine, give a card image as load, say create edit, add 3 loads. S1 is the scale factor, load is lateral, bump, movement. So I'll go to analysis, load step. First I will create lateral SPC as SPC, load as lateral, create, bump. So in this way you can simulate for the cases you want to analyze. The process will be same. Movement, SPC, movement, create, and combined SPC, combine, create. I will save this file. Analysis, OptiStruct, export option to all, run option to analysis, and click on OptiStruct. So my analysis has been completed. So I'll click on results to view the results using hyperview. So I'll turn off rigids and view the results of displacement. When only lateral force is applied, I will also add the animation. Go to deformed, increase the value of animation. So this is how only when the lateral is applied, only when the bump is applied, if I put it like this, so bump is applied. What will happen when only the movement is there and all of them? Similarly, I will see the stresses also. Stresses when the combined loading was there only for lateral, for bump and for moment. So in this way you can simulate the different loading conditions which you assume will come on the knuckle and tries to fail the knuckle. Then we'll go for hub assembly. The process is quite similar. There is a slight difference in the process of applying loading conditions. So rest the process is quite same. So I will create the material first as steel. Give the material type as isotropic, card image mat 1, say create edit. Enter the value of new row. Then a property as hub type 3D, card image p solid, material as steel, create. Update the component with the property. Make the component as current. Go to 3D, tetra mesh, volume tetra, select the surface and keeping the same parameters I will click on mesh. So you can see my meshing is done. So I will click return. Again press F10 from the keyboard and check for the TED collapse. So my TED collapse is quite well here. You can see it's 0.28. So I will directly go for creating the rigids. Say create. In the similar way, I will create for this side 3 nodes, circle center, these 3 nodes, circle center, these 2 nodes, node between, these 3 points, circle center, these 3 points, circle center, these 2 nodes, node between, these 3 points, circle center, these 3 points, circle center, these 2 points, node between, these 3 points, circle center, these 3 points and then click on circle center. Go to 2 nodes, select these 2 nodes and say node between. But here if I want to apply a lateral bump force, I will apply it here and some movement I will apply it here. But I don't have any option to do it on this side. So what I will do now is I will first remove these nodes So this process which is changed here is I will create a 2D face. So I'll go to tools, faces, go to elements, select these elements, enter the tolerance value as 0.1 and click on find faces. So I'll click on F5, select these two elements, say by face, mask, reverse. And I'll go to mask panel again and mask these. Similarly, I will mask this portion. So now I have these as the centers. So now I will create one more component as faces, define a color to it, say create, and move shift F11 and move these meshing to that component and delete the face component. So now I have these faces component. I have to give the property to these elements also. So I will go to property, faces, type 2D, card image P shell, material as steel. So click on create edit and enter the value of thickness as 0.01, which is quite negligible. So I am not adding any weight. I am just providing a basic property with a very low thickness so that whenever I will create the rigids, it will transfer the force to the 3D elements. So again I will go to F4. Select these three nodes, say circle center. Similarly, these three nodes, circle center. Go to two nodes option, select these two nodes, nodes between. I have missed here, so I will create a element here. So I will use this to create an element. So go to three nodes, these three nodes, circle center. Similarly, these three nodes, circle center. Then this node and this one, say node between. Turn off this, F2, shift F2, go to this and this, say clear. Now I will make rigid as the current. So I will create the rigids. So I will go to 1D page rigids, select this node and select the nodes arbitrary at the inner surfaces. Say nodes by face. Click on create. Similarly, this node, some arbitrary nodes at the inner surface. Nodes by face, create. Similarly, here also independent. Nodes by face, create. This node, nodes by face, create. Then I will turn off this. So I will create the rigids here also. So independent node, nodes by face, create. Similarly, independent node, node by face, create. So now my rigids are done. as you can see. So I'll apply the create the load collectors as SPC without card image, say create, then lateral force, say create, bump force, say create, and moment, say create. I will also create one more as combine. I will add card image as load in the similar fashion. So I have three loads to combine, so I will enter here 3. So how many forces you create, according to you will have to give this value. So lateral, bump, moment. Now I will start applying them. So I will first create the constraints. So I will go to SPC, make current. I will turn off this. So I will apply the constraint on these nodes. Then I will go to forces, make current. So I will create a lateral force in negative Z direction at this node, minus 10,000 in Z direction, create. Similarly, bump force in Y X axis of say 10,000 Newton on this node, create. And moment at this node, again negative Z direction, say create. So I will create different load cases as lateral, check the box in front of SPC, load as lateral, create, bump, SPC as SPC, load as bump, create, movement, SPC as SPC, load as movement, create, and combine, SPC will be SPC, load will be combine, create. So now I will save this file in a folder and I'll go to analysis, OptiStruct to solve this file. So there is some error. I will check that how to solve it. So the properties for faces is not updated. So I have to update the face properties. Then I will save this again. Go to analysis, OptiStruct. So if you haven't assigned the properties, it will give you the error. So that error was of properties. So I have updated the properties. So click results. I will turn off faces and rigids and see the displacement values for with the animation. When a lateral force is applied, when bump is applied, when torque is applied, and when the combined loading is there. So this is the values of displacement. Then I will see the values for stresses for the combined loading. lateral, bump, movement, and combine. So in this way, you can find out the values of these stresses and displacement for combine as well as the. Thank you very much for attending this webinar. If you have any queries, feel free to ask us at edu.support@india.altea.com, or you can contact me also. So thank you very much for attending this session.